we're just going to discuss like what we've done and how it relates to what we're about to do, okay? So remember, this isn't new, okay, because we've said this 100 times now. We can always solve a system of linear equations by graphing, okay? And if you want, I'll put 1.3, less than 1.3, okay? That's what we did, okay, in case you're confused, okay? Now you saw when I was plotting those points and I was counting the slope and the y-intercept, it wasn't as accurate. Yeah, Coco?
So when you're recording, are you doing a screen recording so you can like see
Yep.
what you're doing? Okay.
So like, yeah, when you go back, it's just my iPad and my voice. So you can sit there and just like fill out as you go, right? So if you guys wanted to like sit here, the other in D2L I post the solutions, right? So if you're more comfortable sitting here watching and only watching and not multitasking, that's fine too, because I'm going to post it. And then I'll post the solution so you can fill out the note after, or you can rewatch the lesson. It's up to you, okay? I know sometimes like do this for a whole bunch of reasons. That's just one of them. Like if you can't multitask, you just want to sit here and watch, that's fine. Instead of stressing about writing things down, that's okay. Okay, I'll post everything, okay? So you'll notice there were instances, especially on my iPad, where it's very finicky, that I couldn't get the exact line. Like I couldn't get them to go through the points exactly. Okay, this is not, and what I'm trying to illustrate there is it's not necessarily the most accurate method of solving lines, graphing. Okay, so in that second blank there, we're going to put the word accurate. Okay, especially when, if I were to give you an equation that looks something like this. How are you going to graph that? You know what I mean? It's just, you're going to struggle to do that. Okay, especially with some form of accuracy. Okay? What's that? You could use a microscope, or what is 0.1? 0.1. Yeah, so it'd be like up 1 over 100 or something like that. Again, like it's not usable. I mean, that's what I'm about to show you. Is there should not be any instances where we cannot apply something to get an answer. That goes for your purposes, okay? Now there's people doing PhD work that like that's their work, is finding answers to questions unsolved. Okay? You're not at that stage yet. Okay? So we just got to recall two things, okay? So at the point where the two graphs intersect, that's going to be what we call the point of intersection. That has not changed, right? Okay? And then we're going to have each of them, or the point of intersection is going to have an x value and a y value. Okay? So let's just, I'm going to skip one for a sec because I think 2 is easier and I want to show you something. Okay? You guys will recall this because we just finished doing it. What did everybody get? 12, okay? There is a fundamental skill that you guys did in doing this, okay? And if I go back to it, okay, what I saw was very good, right? Instead of drawing, it does a couple things, okay? It makes you think in a very methodical way, but also I saw some people going like this. F, 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 umbrella, tree. They're assigning letters to pictures because we don't want to draw it 400 times, obviously, right? Which is good, okay? These are now what are just called variables, okay? And the things we're after, we just want to solve for the variables so that we can get the final question mark, okay? You guys did this. So you would have found f was equal to 3. Then you took f equals 3, and you were like, okay, well, there is a fire here, but there's some other stuff that I don't know, right, in the second one. But then you found the fourth one. If I plug in the value of f equals 3 in as fire, I could find tree. That's what we're doing with substitution. Okay? It's not maybe as straightforward in the sense that we don't get just a solid number, but I'm going to do something with this. So let's do number 2 here first, okay? What I'm going to do is I'm going to get rid of the variables here for a sec. Okay, and you guys can draw this on here too. Okay, so I'm going to have squares and triangles. What I want you to solve or do with this, and I'll guide you, is to find what one square is equal to and find what one triangle is equal to. Just like your fire umbrella thing. Okay? I'll do it with you. Okay, but that's the idea, yeah?
Just for substitution, does it matter if you isolate x or y?
Nope. Doesn't matter. Okay? So what you'll notice, sometimes I won't be nice and I'll give you equations that aren't isolated for a variable, okay? Or a shape in this question, okay? By that I mean, in the second one you can see how the square is already isolated. Square is equal to triangle minus 3. Okay? So what you can do, the whole point of this is like, okay, if one square is equal to a triangle minus 3, where else do I see a square in this question? Right here. In the other equation. Right? If one square is equal to all of this, then why can't you take this and plug it in there? That's what it's telling you to do. 1 square is equal to triangle minus 3. Is anybody freaking out? Okay? It's just a shape. It's just like your fire question with your umbrellas and trees. You're going to find something in terms of the others, and then you're going to plug it into the other equation. Then you're going to notice something when I do that. So I'm physically going to basically delete this thing because it's gone now. I'm going to write it in terms of this. So I'm going to go triangle minus 3. Right? That's 1 square. That's what we just said, right? Plus 3 triangles is equal to 9. Right? Is everybody okay? Your goal with this is to find or tell me what one triangle is. Right? So we're just gonna solve this like, I don't know, the homework from 1.2 or 1.1. That's all it is now. I've got numbers and I've got some variables. I'm gonna collect them, or I've got some shapes. I'm gonna collect them and then tell me what one triangle is equal to. Okay? You can basically ignore the fact that the brackets are there because I just put them there to illustrate a point. Okay? The point being I was making the physical substitution for what 1 square was. Okay? Now, I'm going to physically take, I'm just solving this. I'm going to take the 3, the minus 3, and we're going to move it to the other side. When I do that, or how I do that, is to add 3 to both sides. Okay? Then they cancel each other. So then the next line is going to be this. Triangle plus 3 triangles is equal to 9 plus 3. Now I can collect these because they're like terms. Okay, so 4 triangles is equal to 12. Divide both sides by 4. So 1 triangle is equal to 3. Are we okay? This isn't an easy concept. It's hard to I don't know. Hard to keep track of. You okay, Paul? Yeah?
Yeah.
Okay. Okay. It's not easy. Okay? And it only gets harder when you start mixing in fractions and stuff, right? But the idea doesn't change. Right? Now, are we done?
No.
Okay. I have something else on my page. Remember what we're after. And this isn't as clear because I've changed the variables into shapes. But remember what we're after. We're after a point of intersection, ultimately. So I should have two pieces. In theory, I should have an x and a y. In this question, I changed the triangle to a y, and I changed the square to an x. Or the x to a square. So I have the y. It's 3. Yeah, Coco.
So if so say if like the bottom one says like x equals, so then the triangle is 3 minus 3, so that's like 0, right?
Yep.
So is x 0?
Yep. Okay, did everybody see what Coco just did? I found what one triangle was, but I have something else on my page right here. It's going to tell me what a square is. 1 square was equal to the triangle minus 3. Well, I found what the triangle was. This is like your fire question. Just plug it in. So 1 square is equal to 3 minus 3. So a square is equal to 0. Now the squares and triangles may or may not be helpful to you. I don't know. You could do. I don't care what you do. You could solve. You could do happy face and frown face. I don't care. It doesn't matter. They're just something that you're solving for, right? If you want to leave it as x, like remember what it is. Underneath there is just an x. That's all it is. And the y's are triangles. Okay. Then when you're able to plot it at the end, right? That make sense? Let's go back to the top one, okay? We'll do the top one. And the top one's a little bit different. You can see how this one's nice, right? Because x is equal to something over here. Okay, those are nice questions. What isn't nice is if I give you two equations that look like this one. Then you got to isolate for one. Now you got to make a decision, which one do I want to isolate for, the easier of the two. Like in the first one, I would have isolated for x, right? Because all I would have done is move the negative, or the 3y over, and it would have become minus. It would have had x equals something. It's the only way for me to make this more difficult, aside from introducing fractions. Okay? So let's go back to the top. This is an ideal situation. Okay? It's ideal in the sense that if I go back here, I'm not going to do this question with squares and triangles. I'll erase them in a sec, but I'm just trying to illustrate a point here. Okay? I've got a triangle equals that, and a triangle equals the other thing. They're already both isolated for the same shape, right? Well, why can't you, if they're already like this, then why can't a triangle equal a triangle? Does that make sense? No? Okay, let's not think of it that way then. I have a triangle is there, and I have a triangle here. One of the triangles is equal to this thing. Then why can't you go like this? Is that better? Both of these are triangles, because it told me so. This is like a little hard to wrap your head around at first, but this is like your ideal situation, because you just want to make the two equations equal to each other. Because it's telling you that y is equal to something, and it's also equal to something else. In that instant, you can make them equal. So let me just, before you guys write that down, I'll write this. Is that better? If I were to replace these now, I'm going to go back. Because I don't want it, as much as you might find this, it doesn't really matter actually to me. You've got y equals a piece. Y's got to equal another piece. So why can't the two pieces be equal to each other? You mean? This is an important step, so I just want to make sure everybody's okay. It's I don't know. It's hard to wrap your head around this, but this is the situation. This is the ideal situation, right? When you have y equals something, and y equals something else, these two something else's must be equal. That's all I've written here, right? So now once you're at this stage, I can basically get rid of the y in the middle. And I can solve. I don't see any more y's anymore is the point, right? I only see x's, so I can solve for it. Okay? I'm going to take this and I'm going to move it over. I'm going to subtract 3 from both sides. 3x, sorry. And I'm going to take the 5 and I'm going to move it to the other side and add 5 to both sides. Okay? I get negative 5x is equal to 10. X is equal to 10 divided by negative 5, which is negative 2. What do I do with that now? Do I have something else on my page that allows me to find y after I found x? This is my question. What would happen if I plugged in x equals negative 2 in there? I get a y spat out on the other end. That's what I'm after. I have the x portion of the point of intersection. I want to find the y. You could pick either of them, right? Doesn't matter. If it's a point of intersection, it means it satisfies both those lines. We learned that on Friday, right? Okay. So if I plug in the x value of negative 2, it doesn't matter. We could do y equals 3 times negative 2 plus 5. Negative 1. Okay, which makes my point of intersection negative 1, negative 2.
So, but shouldn't it be like negative 2, negative 1?
Sorry, you're right. Good catch, you guys. Look at you guys go. There you go. Are we okay? There are a few things in this course that are like, I would say, well, there's obviously always stuff more important than others, right? As we've alluded to with Paul, right? But this is like, from this entire section, right? Like, this is the skill that you're going to take to all sorts of places. Okay? Just this idea of like writing something in terms of other things and then substituting it. That's a very powerful skill. It's very transferable too. Okay? So it goes way beyond just solving for a point of intersection with lines. It's the ability to flick the switch in your head to like, I'm going to find this in terms of other things and then allow it to solve problems for me. Okay? Substituting it. That's powerful. Especially if you take physics. I talk about physics a lot because it's my other teachable. It's in chemistry. I don't know if it'd be in this bio as much, but it'd be in chem. Okay. Everybody okay? Trying to see what else we got down here. I've got 4 of them. Okay. And then I've got a homework sheet for you guys too, okay? This is an instance, okay, this is a perfect question here, okay? This one's not so nice. This on the back, yeah? You guys okay? This one's not as nice. Why is it not as nice? I don't have x equals this. I don't have y equals this, right? I gotta have there's just one more step ahead of doing the work for this question. I gotta get one of these variables by themselves, right? Either x or a y. Okay? Really, I would go with the easier of the two. Whatever one looks, and the word easy is relative to each of you. Whatever you look at, to an extent, whatever you look at and go, okay, I can get this pretty easy. Whether it be x or y in this question, okay? The point is sometimes you have a little bit of work to do before you can start the substitution phase, okay? And it's just got to get the variable by itself, right? So with this, I'll solve for x. Is anybody opposed to that?
Yes.
Well, you want me to do y? Okay. I'll solve for y. So what are we going to do? I just need y equals something, right? Like y equals mx plus b. Well, it's sitting there by itself, and I can take the 2x and move it over to the other side, okay? So I'm going to get negative 3 minus 2x. Okay, now I have y equals this piece. Remember, this is just the second equation rewritten. Once I have this, I'm going to use the other equation to substitute into. So I see a y just sitting here, right? Y is equal to this piece. So in the first equation, I'm just going to rewrite the first equation with this piece in there. Okay? X plus 2 times negative 3 minus 2x is equal to 1. Okay, everybody see, is the color better? I'm trying to do this as many ways different as possible. There's shapes, or if it's the variables, if it's colors, whatever, right? Everybody see what I did? Okay. Now it's just math. There's no more thinking involved. It's just expand. Okay. So that might be a new word for you. Okay. We're gonna have. I'm just gonna get rid of. We called this getting rid of the jail bars on Friday. Remember that? Okay. So we're gonna multiply over to get rid of the brackets. So we're gonna have x plus 2 times negative 3. That's the first one. Which turns into negative 6 minus 4x is equal to negative 1. Okay, I put the brackets here. This is a good all-around lesson. I put the brackets here to separate the minus 6. What's more powerful, a minus or a plus sign?
They're kind of equal, but
Are they equal?
minus.
The minus always eats the plus. Okay? Yeah, Kolo.
So how did the 1 turn into a negative?
Which one? Sorry.
Like the equal.
Oh, sorry. I'm just doing crazy things now.
So
Sorry.
Just 1.
It's just 1 still. I haven't touched anything on the right side. It's still 1. Okay? This right here is like positive 1 multiplied against the negative 6. That's what I mean by which one's more powerful. The negative always dominates the plus. Okay? Which is why I separate with the brackets, just so you can see that, right? So your line here is just going to be basically x minus 6 minus 4x is equal to 1. And all you got to do is get this to the other side, right? By adding 6 to both sides. It's not that boring. I think it's kind of exciting, actually. The problem is I can't tell who y'all because y'all got masks on. Right? So I'm going to move the negative 6 over, which leaves me the x minus 4x on the left side is equal to 1 plus 6 on the right. Okay. And what are we going to get? I get 1x minus 4x. That's going to be negative 3x is equal to 1 plus 6. I would prefer if you left it like that, but I know some of you are going to type this in your calculator and get what? Well, what is it? 2 point. Okay, so what's the problem with this? It's not exact, but that 3 goes on forever. That is a perfect example of why we like this.
You also just write to negative 2
Like that, you mean?
like write it in like a mixed fraction.
Well, yeah, you could, but that's the problem with mixed fractions is like when you go to plug them in again, what do? Starts to mess things up a little bit, right? That's why I think we teach the mixed fractions. They're like proper and improper. Okay, am I done? So the problem with this is like, how are you going to identify negative 2.333? How is that different than, like visually on a graph, how is that going to be different than 2.44? Negative 2.44. You're not going to be able to distinguish that. That's what the algebra is for. Because now, and here's the other thing, if I take this number now and plug it in for x over here, my answer is not going to be perfect. Right? Because I've rounded. I have rounding error built into what it is I'm doing, which is why we leave it as a fraction. Okay? So, I'm going to replace it in number 1. I just got to get y by, I got to solve for y now. Okay? Oh. Is that the smart thing to do? Anybody see what's wrong with what I just did? There's nothing wrong with what I just did, but I did extra work for nothing. I already have y isolated. I plug in x, and the question's over. Why would you re-isolate over here? Did we see what I did? So you've got y equals already. Why don't I just plug the x in to right here? It's going to tell me what y is. Right? Sorry to get messy with the blue highlighter. Okay? The point is, you could plug this x value into either of these two equations, okay? Either of these two guys here, 1 or 2, you could pick. So the next step here would be like plug x equals 7 over negative 3 into either 1 or 2 to find y. The thing is, I already took 2 and rewrote it in terms of y. Okay, it's already sitting here by itself. Which means I can go y equals negative 3 minus 2 times 7 over negative 3. This is where things are going to get interesting. Okay? Remember, I'm just after y. So y is equal to negative 3. I'm going to multiply fractions here. Top times top and bottom times bottom. Negative 2 times 7 is going to be negative 14 over negative 3. Okay? Remember the 3 is over 1 there, so that's not very useful. I'm going to have to, in order to add and subtract fractions, I got to get the denominators to match, right? They don't match. Got to make them match. How do I do that? If I multiply by negative 3 over negative 3, sorry, I'm consuming the bottom portion of this page. Y is equal to 9 over negative 3 minus 14 over negative 3. Now the bottoms match. I can just do 9 minus 14. What is that? What's 9 minus 14? Okay. Not so nice of a question. Okay. So then you can state your final step. You always have to state what your point of intersection is. The x value we found to be 7 over negative 3. And the y value 5 over 3. Okay. I'll write down here. I'll give you some rules here down at the bottom, okay? We won't do 4. Don't worry about 4. I want you guys to have as much time to work on questions as possible, okay? All the ones on the sheet that I'll give you all work out nice numbers. There's none of this fraction stuff. That's really not the point of this, is to deal with fractions. The point is the substitution piece. The fraction illustrates to you guys why it's probably better to use the algebra versus the graphing. That's the point. Okay, that's why that's in there. Okay. I'm not going to test you on how well can you deal with fractions. Okay, the fractions are there because it's a little bit more real world specific. That'll probably be the test after Thursdays, right? But the idea is that you're able to just take something and plug it into another to get both pieces. That's what's important. Okay. So down to the bottom, I'll write some rules here for you, and then I'll give you some time to work on some stuff, okay? So step 1, I'll say, actually, you know what? I'll just drag this over. I'll write it on here, never mind. So isolate one variable. From one equation, okay? And pick the easiest one. Substitute the isolated Okay, so you're going to substitute the isolated variable from the first one that you just found into the other equation. Okay, so the other one could be number 2. Okay. And then you're going to collect like terms and solve for the variable. Once you have that variable, you're going to take the variable from step 3 and plug it back into and then your last step is state your point of intersection. Okay? All the questions I gave you guys on the homework sheet, okay, will all work like this, these two guys. I'll move that down again in a sec, okay? They'll all work out to be like nice numbers like this, okay? I didn't give you any ugly ones just to get you into the swing of things, okay? And all the answers are at the bottom of the page, okay? I'll leave this up here. I'm gonna hit stop here, okay? And then